Life of Fred. The trick class waited 20 minutes. Then they cut a giant piece of the cake, put Fred's name on it, and took it to the rec room fridge. They looked at each other and said, "What would Professor Goss want us to do now?" The answer was clear. They headed back to the classroom and consumed the rest of the cake and pizza and drank toast to Fred with their glasses of sluice. Joe offered the toast. "To our beloved teacher who has more wonderful stories than there are natural numbers." "Wait, Joe, that's crazy," said another student. "The natural numbers are 1, 2, 3, 4, da 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 da. There's an infinite number of them. How are you going to have a set like that, like the set of all Fred's stories with more elements in it than the natural numbers?" An English major pleaded on Joe's behalf. "Permit Joe his little bit of hyperbole. After all, it's only a toast." For non-English majors, we note that the hyperbole, pronounced hyperbole, is an exaggeration, not meant to be taken literally, such as, "I bet you $1,000,000 that." Joe was trying to defend himself, argued, "Hey, there are sets with more elements than the natural numbers. How about the whole numbers? There are 0, 1, 2, 3, 4. Who was right? The answer, no one except the English major who asked for tolerance. Here are the corrections to the errors. Number 1. Joe wasn't correct that Fred had an infinite number of stories. As we pointed out in Chapter 1, there are only about 10 to the 79th atoms in the observable universe. So anything tangible, like the puffs of air it takes to tell Fred's stories, is necessarily finite. Number 2, when the students said there weren't sets with more elements in them than the natural numbers, he was wrong. There are such sets. Number 3, when Joe said the set of whole numbers has more elements than the natural numbers, he was wrong. How can these things be true? The truth is, A, the set of natural numbers, the set of whole numbers, the set of integers, and the set of rational numbers, which are defined on the next page, have the same number of elements in them. B, there exist sets that have greater number of elements than any of the sets listed in Statement A. How is this possible? There are many real surprises that await you in your study of mathematics. This is one of them. When mathematics discovered less than 150 years ago, the statements A and B were both true. Many of them had a fit. Impossible, some of them screamed. It wasn't that some math guy said that he thought A and B were true. Instead, some math guy proved that the sets that have more elements than the natural numbers. These statements are laid out and proved in the first chapter of Life of Fred, Calculus, which isn't that far away for you. After the book you're holding in your hand, there's only advanced algebra, geometry, and trig before you open the pages of Calculus. Rational numbers. That's the set of all possible fractions, including 1/2, 3/4, 97ths, -3/8, 44 1/3, 0 13ths, 1 and 100,000, and 7 21ths. The rational numbers also include any numbers that can be written as a fraction. So 5 is a rational number because it can be written as 5/1 or 20/4. The rational numbers do not include pi, since that can't be written as a fraction. Officially, the rational numbers is the set of numbers that can be written as an integer divided by a non-zero integer. There's your definition, rational numbers. It would be hard to use braces and just list all the rational numbers. If I try, it might look like 1/2, 1/3, 1/4, but that doesn't work since I left out, for example, 3/8. It would be hard using braces to just list that set of all four-legged animals. If I tried, it might look like horse, mouse, cat, dog, rabbit, ibex, elephant, but I'm sure I wouldn't be able to list them all. Would ibexes have been on your list? I don't know what that is. Here's a new way of writing sets that will help us out. In English, the rational number is the set of all x such that x equals a over b, where a and b are integers and b is not equal to 0. Using symbols, the rational numbers are defined as x, where all x's equal a over b, where a and b are integers and b is not equal to 0. The symbol means not equal to. The three symbols, x with the line, are read the set of all such x such that. That's called set builder notation. So that's what the trig class was up to. The chancellor had called out the campus police. It was against university policy for anyone to kidnap faculty members without permission of the administration. This regulation had been patterned after Article 114 of the Weimar Constitution of Germany. Personal freedom is inviolable. No restraint or deprivation of personal liberty by the public is admissible unless authorized by law. The campus cops caught up with Sergeant Snow and his buddy as they were sticking 6-year-old Fred in the military transport vehicle. A very brief argument ensued, but was resolved as many arguments have been resolved in the history of the human race. Namely, Sergeant Snow had a gun and the campus cops didn't. The university police made Sergeant Snow a temporary member of the administrations of kittens, and thereby no university regulation was violated. So that's what Chancellor and the university police were up to. And Belinda Bright, she was headed to her office and worked on the new stack of envelopes that Fred had handed her just before his abduction. She had been working more efficiently ever since she had took that Work Speedier and Get Richer seminar for $789 last summer. She never opened any of the letters that Fred gave her. She just copied the return address off the smelly envelopes and sent out the letter, "Sorry, he's already taken," and tossed the unopened envelope into the garbage. She copied the return addresses of the job offers and sent out the form letter, "Sorry, he's happy where he is." She copied the return address off the request for interviews and sent out the form letter, "For answers to all your questions, check out the Fred's website." Somewhere in the above description of Belinda's Work Speedier approach is the key to what happened to Fred. So that is what Belinda was up to. It was Belinda who was most distraught by Fred's disappearance. She had known him since he first came to Kittens. He was only 9 months old at the time, and Betty used to carry him to class since otherwise it took him too long to get down the hall from his office to the classroom. She had eaten many a pizza with our young hero over the years. She was in tears by the time she found Alexander in the student rec room working on his PhD thesis. He stood hearing the story of his muscles involuntarily flexed as adrenaline poured into his system. Actually, adrenaline is the old name for the hormone that's secreted in response to fight, flight, fight situations. The new name is epinephrine. With epinephrine, your heart beats faster, your blood pressure rises, and your blood clots more quickly. That's great if you're going to wrestle a lion, but not so good nowadays. The usual sequence of events is stress, epinephrine, increased blood pressure, faster blood clotting, stroke, heart attack. But Alexander wasn't thinking of heart attacks right now. He ran to Belinda's office and then to the chancellor's and found out who had taken Fred and where they were headed. He cell-phoned Betty. She got in her car and they met at the south end of campus. They had a long drive ahead of them. "Did you find out where they're taking him?" Betty asked as she drove toward the freeway through town. "Yeah, Lampasas. It's in Texas, and they've got a 1-hour head start on us," Alexander replied. "Apparently the Army has rounded up a whole bunch of induction evaders, and a whole caravan of paddy wagons is headed south with their prisoners." She pushed her car to the speed limit, 65 miles per hour, as they climbed onto the freeway in pursuit of Fred's abductors. Now, as everyone knows, Army caravans travel at 45 miles per hour. But they had two advantages over Alexander and Betty: 1 hour head start and guns. How long before our friends of Fred caught up with the army caravan? So here's Kittens. Here's Alexander and Betty. Here's the army caravan. And here's a little place in Texas they're going to. We need a formula for motion. If you travel at 30 miles per hour for 5 hours, you will go 150 miles. The formula is distance equals rate times time, where D stands for distance and R for rate and T for time. We want to know how long Alexander and Betty will have to drive to catch up with the Army vehicles. So we'll let T equal the number of hours they will have driven to catch up with the Army. In many algebra problems, after the first step is to assign a letter to the quantity we are trying to find the value of. This is important. So you put X, or whatever letter you want, they use T to find the unknown value. What else do we know? After Alexander and Betty had driven T hours and caught up with the Army will have driven T plus 1 hours. How do we know that? We've told you that the Army had a 1 hour head start. If, for example, A and B have to drive 18 hours, then the Army would have driven 19 hours. How far will A and B have driven? Using D equals R times T, they will have driven 65 times T. They will have gone 65 miles per hour for T hours. How far will the Army have gone? Again, D equals RT. The Army will have gone 45 times T plus 1. They will have gone 45 miles per hour for T plus 1 hours. We have one last fact that we can use. Namely, we know that when A and B catch up with the Army, both parties will have gone the same distance. They both left Kittens University and headed south on the same road, and when A and B overtake the Army, they will have covered the same number of miles. The two distances above are 65T and 45T plus 1. So, these two expressions are equal. 65T equals 45T plus 1. To solve this motion problem, we use the formula D equals RT. To solve this equation, we're going to need the distributive property. Please look at these examples of the distributive property and see if you can see how it works. Look right here. We've done this before, so I think y'all know how to do this. We tend to write numerals before anything else, so we write 4 times pi instead of pi times 4. They mean the same thing. Pi squared means pi times pi. We'll talk about that in detail when we get to exponents. The last line is the distributive property. A times B plus C equals A times B plus A times C. We'll show why the distributive property is true in Chapter 4, but right now we've got to find out the solution to 65T equals 45T plus 1. So we can find out when A and B will catch up with Fred. So here's our problem. Distribute, multiply the 45 times the T and the 1. Now we're stuck again. We've never had the unknowns, in this case T, in two different spots in an equation. The trick is to get the terms containing the unknown on one side of the equation. So we've got T on two sides, and we need to get them to one side. And the numbers on the other. We have 65T on one side and 45T on the other. Watch what happens when we subtract 45T from both sides. 65T minus 45T makes 20T. 45T minus 45T makes 0, which just leaves us a 45. That's a lot nicer, isn't it? T equals 2.25, so 2 hours and 15 minutes, dividing both sides by 20. You could have written this last line as T equals 45 over 20, or as T equals 2 1/4. They all mean the same thing. So Alexander and Betty will have driven 2 hours and a quarter hours to catch up with the Army vehicles. That's plenty of time for your turn to play.